My name is Majenta Strongheart. I'm Director of Supplyframe's Design Lab, and I'm very excited to welcome to our Supplyframe Electronica stage, Andrew from Siemens EDA. Thanks for joining us today.
Thank you very much, Majenta.
And so I realized that you said it was your first Electronica, so I'd love to just hear kind of first impressions at the fair this year.
It's big. I knew it was big. I didn't realize how big it was. It's interesting. It's a bit overwhelming at times, but it's really, really interesting. Fun.
Yeah, it's like a big reunion, I feel like. Every couple years we get to see all our old friends, meet new friends, and really engage with the our collaborators and partners across the industry. So just to kind of help everyone get an introduction to your role, I think you have a few slides prepared where we can learn a little bit about what you do at Siemens EDA.
Yep, sure. So I am a product architect at Siemens EDA. I look after a certain business stream on the EDA side. This is PCB design tools. So I control the whole, if you like, the whole data process for our PCB design, looking at new platforms, new customers that we can bring in. I'm kind of referred to as, well, what we do is referred to as the sausage factory. All right, and we are the sausage makers, and it was pitched to me when I joined this role, if you want to be involved in what goes in the sausages, this is the role to take, which is kind of ironic for me because I'm a vegan, but sausage making is for electronics is what we do.
Yes, good thing that it's not actual sausages.
Yeah. So we're going to talk about some new imperatives for resilient components, and I'm going to go through a little bit about our new release, what it is, and I think Majenta will dive in a little bit deeper with me. Okay, so this slide is really charting the kind of progress that EDA has made. So we started in the 80s, and in the 80s we had a lot of separates, or it's almost like silos or separate bits and pieces for different parts of the design flow. And then once we progressed through time, we got to the 90s, we started to have a bit more of a methodology. So you'd have EDA companies that were then selling a suite of tools to cover that methodology. And then we got to the 2000s, and we start to look at multi-domain design. So we're not just looking at electronics, we're looking at how we build electronics, how we integrate into something like a PLM, how we look at the supply chain, how we look at mechanical, thermal, electrical. So it was building out, because we know that a PCB, when you design it, doesn't exist in isolation. It builds into something, it connects to something, it plugs into something. So when we design a product, we basically want to build a digital twin. And that digital twin is evolving now to include AI. It is also evolving on the component side, on the library side. Libraries are the be-all and end-all of EDA, where your libraries are, how structured they are, how good they are. And the supply chain part and the data that we get from supply chain is more and more integral to our design process. So when we get to now the 2020s, we've got our full digital twin, but we're also starting to integrate AI into that. We're also starting to integrate a new platform. So our new platform is kind of leveraging everything we've done previously up to now. So we're categorizing ourselves as quite mature in a digital transformation. In 20 years' time, we'll probably look back and say we're very immature. But for now, we look at the way we've designed and the way that customers design. We think we're doing a pretty good job, and we understand the needs of their environment, their design needs, their supply chain needs, and we understand that a lot better. And this has helped them combat a lot of problems, issue areas they see. So we see reduction in decent headcount or staff, applicable engineers for roles. We see complexity increasing. We see lots more constraints putting on in the engineering flow. So we are pretty adamant that we will adjust and help the engineers design products quicker, faster, with more information to their fingertips. Okay, so the new platform that we have is called 2409. It's our new electronic system design platform, it's next generation platform. It's got these 5 pillars that we have introduced and are very much the ethos of how we design and how we give a product to our customers. So it's intuitive. That means that we understand that there is a younger element coming into our workforce. a lot of our people are what I would call, grumpy old PCB designers, and they work in a certain way, doing things their way. So they get from A to Z in a certain process. The younger workforce doesn't quite have that knowledge and that experience in their design life at the moment. So our tools have to be intuitive. It has to guide them. And we do this by making the tools intuitive, making the flow intuitive, thinking of the methodology, having different ways that they will work. But we also have AI infused in our platform. And we couldn't really have a product without having AI in it. You've got to have AI in everything. So we AI the sausage making, if you like. And we're not saying that AI is going to take over our whole process. At the moment, AI is infused. So there's a gentle, smattering of AI in our tools to give customers the edge where they think they need it.
Help strengthen what you guys are already doing.
Yeah, exactly. So, we're talking about that, the younger workforce AI is there to bring them along and help them do a product quicker, not necessarily take over them. Everyone would love a big red button that says design it, okay? And that may happen, not in my lifetime though. So, AI is key to what we do, but it's a gentle AI.
And also help track and retain the knowledge of some of those more experienced engineers that are on the teams that are passing off the work.
Really, really good point, because some of the engineers coming in don't have the knowledge. So part of our AI is to have a local language model that learns from the user. So everyone starts with a basic model. And so one area we do this is command prediction. So we know that if a designer designs a board, he typically takes the same steps every time. We're creatures of habit. So they will place a component. The next step they will do is rotate a component. They may push it to the other side of the board. All right, so our command prediction looks at those steps. If it goes into place mode and picks up a component, the command prediction knows that more or less he's going to rotate, and that'll be the next command that becomes available. He knows that maybe he's going to push, and that'll become available. He knows he might want to turn it 45 degrees, trim some pads, add some connections, so they become part of the command prediction. And then we can have senior engineers that have their own model and build up. And so the model learns from them, it gets added to by them, and when we can share that model with everyone in the organization and let someone's experienced AI model help drive their prediction and help them through the steps of doing the design process.
That's huge. It's like that 20% to really get you started and get a running start going.
Exactly. And that's what those engineers need. I mean, everything is becoming more and more critical to get up and running quicker. If we looked 30 years ago, the life cycle of an electronics product was about 40 years. A decade later, it was 20 years. A decade later, it was 10. And now at the moment, it's about 4.5 years.
Wow.
All right. So, everything we do has to happen at speed. It's like EDA on speed, if you like.
Moving faster and faster.
Faster and faster. Cloud connected is also another, one of our important pillars. We use the cloud connection so we can collaborate more with our customer base, and our customers can collaborate with the right people. All right, so we've got a cloud connected platform that allows them to share and collaborate on data. Let someone else to review it, let someone else to mark up, give comments, share data where data is relevant. Integration talks to that wider digital twin that I mentioned. So our tools are integrated, they're highly integrated. The integration, capability floats up and down the platform. So we have a scalable platform, which is, less technology at the lower end, more technology at the higher end. The higher end is typically aimed for enterprise. Enterprise have a lot of demands. There's a lot of configurability, a lot of customization that needs to happen. So the integration there needs to model that, needs to allow it to accept the different configurations that we have at enterprise level. But at the lower end, you typically find it's maybe an out-of-the-box integration into PLM, for example. So it's more bespoke at the higher level, lower level, more out of the box. Then lastly is security. Whenever we're sharing data, whenever we've got data at rest, our data needs to be secure. Our customers expect this. It's demanded by them. So we put a great bit of emphasis into looking at how secure our data is, whether it's in transit, whether it's at rest. We give our customers control over where the data is accessed. So we have geographical data restrictions, for example. So if you work in the US your data is freely available, but if you're off and you're working out of the US for ITAR reasons, something like that, the data is not accessible. So those 5 pillars make up, our ethos when we're designing our new platform. Okay, electronic components are a key part. I mentioned that. So we would love to have a digital twin that encompasses everything from component vendor all the way through to release. At the time, it's not really possible to do that because of the way the industry is at the moment, but that is what we're moving to. So we try and put a digital thread into as much as we can in our digital platform. Okay. And that's the end of my presentation.
And so we talked a little bit about, you mentioned some of the constraints that engineers are facing these days and how important it is to not be working in silos and really have this connected tool that reinforces more connection across teams in their workplace. And so what are some of the challenges you've heard in conversations at this event, over the last 2 days? What do you think the biggest challenges engineers are facing are?
One of the biggest challenges, I would say, is component sourcing, supply chain, which is where Supplyframe comes in. As I mentioned, it's the core building block of everything we do on the design side. So we've got to have a really good, resilient supply chain. If we don't have that, then everything, it doesn't matter what they're designing. If we can't get it made, then we're in big trouble. So I would say supply chain is one of the core areas, and then moving on from that, integration and digital threads.
Of course. And, of course, we talked about supply chain resilience. When it comes to that, what would you say are the key characteristics of a resilient component?
So a resilient component, I would say there's a couple of different areas that you look at. One of it is to make sure that you can source a component, you can reliably get that component at a cost that's acceptable, at a lead time that's acceptable. So that's probably the biggest part, the resiliency of the component. Can I get it? If I can't get it, then why am I designing it into my product? So it's got to be something that's achievable. So that comes back to that digital twin as well, the next part. A resilient component is something that you can use and utilize and leverage as much as possible. So ideally, we would have a full digital twin of a component from an electronic model of the data sheet. At the moment, a PDF is our prime format for data sheets. So you've got a component manufacturer that takes an electronic format, puts it into PDF, puts it into paper, and then we kind of consume it from there. And that should be part of our digital twin. So first and foremost, I say, is the availability and the reliability of what you are sourcing from your components. And secondly is increasing that digital twin.
You mentioned a few times, kind of these older processes that we're trying to, make more efficient and really provide a tool that helps bring these into the now. And how do you feel, what are some of the challenges with getting adoptees to this sort of thing? You've talked about people are used to certain processes on paper, in spreadsheets, et cetera. What are some of Siemens, strategies to get them on board with this tool that obviously offers so much?
Yeah, the tool is quite extensible. It's quite flexible. So every customer we work with has a different process. So flexibility is key. Having the ability for your tool to be flexible and allow it to adapt for company A, company B, company C is really, really important. I would say one of the big challenges we have is probably workforce. We cannot get workforce in quick enough. So when we do get workforce in, what we do is important. So having a methodology that we use, having a consistent, repeatable methodology is really, really important.
And you teased a little bit this, this new launch that you guys are promoting here at Electronica 2409. Can you tell us a little bit more about how Supplyframe's design to source intelligence is being integrated into this and helping round out the offering here?
Yeah, it's a really good question. When you design a product, you typically, you've got an idea in your head what components you want to use, and you start with that. They may be in your library or wherever, but they're pre-existing. And normally, up to now, I would say what is in your library is a static view of data. It's the component, and it sits in your library, and there's no link to the supply chain. The way that we work with Supplyframe, we have got Supplyframe heavily integrated into a couple of areas of our design process. So one of them is right at the beginning in our, platform, or our data management platform. And building libraries is part of data management, or data management is part of building libraries. and we use Supplyframe as a digital thread into our library. Okay, so now we don't have to go out to a data sheet. We don't have to look at or figure out what the metadata is to come into our library. We have Supplyframe do that to us. And Supplyframe is buried into our tools. So librarians would use our tools to search Supplyframe's database, take the relevant metadata they want, embed it into our library, and then that becomes part of our database. So that's one area. The other area is from the designer point of view. So when a designer designs a circuit, he probably needs a dynamic view of what the marketplace is telling him. And again, that's where Supplyframe comes in. We have a supply chain app, which is powered by Supplyframe, which gives the market view of components. What the stock levels are, what the location is, what the costing is, what the risk factors are on those components. So that is buried into our tools at the design stage. So our designers know that as they are designing something, if something is out of stock, they can use the app to look for alternatives. So they can pivot to another technology if need be. So those are the two core parts that we are using Supplyframe embedded into our design flow.
And they can see some of those characteristics you mentioned earlier of a resilient component at the design phase.
Exactly. Yeah.
And so what are you excited about for the future? After launching this new tool and seeing the conversations that are happening here, what are you looking forward to for next year, 2025, in the industry, and seeing how engineers are coming together around this digital thread?
First and foremost, I would like to see wider adoption of the tools. So I want more customers using it.
That's why we're here talking about it, right?
Exactly. So everyone go out and buy the tools. I'd like to see wider adoption of the tools, and I'd like the understanding from our point of view that we can support customers and looking at the supply chain side of it more, deeper, better, and that helps you design product. So I see that as being an extension of what we do in a year's time. Also, there's certain markets we haven't really looked at from a Siemens point of view. We haven't really looked at, say, an SMB or an SME market. So we are taking the technology we have, which we aim at enterprise, and moving that down to an SMB, SME market. The same philosophy, same tools, maybe slightly different application of them. But the way we design with as much of a digital thread as we can is key, and that will continue going over next year and the year after, the next 5 years as we go forward.
That's awesome, making it more accessible to a broader group of individuals to take advantage of.
Exactly, yeah.
Very good. And so is there anything else you'd like to share with our audience here today, or where they can learn more about 2409? Obviously, you can visit the Siemens booth next door.
Yep. So the Siemens booth is in A3. We've got rolling demos all day. We've got application engineers willing to talk to you, willing to take your checks and your credit card. Online at Siemens EDA, we've got all our platforms listed there. I'll be floating around, I'll be here, I'll be over there. So if you want to see more information, if you'd like a demo, if you like just to sit and look at one of the rolling demos, we can do that. We've got a private demo booth as well. So please come over and talk to us.
Awesome. Thank you so much, Andrew.
Thank you so much, everyone. Thank you.